Hello everyone. Today I have a question for you guys. When someone takes a loan from the bank, do you think they return the exact same money or do they return more? Exactly. That extra money is called interest. So today we are going to learn how to calculate both simple interest and compound interest with clear steps and real examples. So without wasting time any further, let's do some math. So now first we'll try to understand what's the difference between simple interest and compound interest, and then after that we'll solve and practice a few questions. So if you don't have your pen and paper with you, do bring a pen and paper. Try to understand the difference between simple interest and compound interest, and then we can practice questions. So here I have framed a question. Let's say let's say I'm investing $225 at 7% rate of interest for next 3 years at simple interest, and the same case $225 for 7.5% per year of rate of interest for 3 years at compound interest. And let's see in which case we'll receive more money. So in case of simple interest, if we have to calculate the simple interest, the formula is SI is equals to P into R into T multiplied by 100, where P is the principal amount, which is the initial amount that we invest, R is the rate of interest, and T is the time period. So let's find out the simple interest first. So simple interest is going to be P, that is 225, R that is 7.5, T that is 3 year, divided by 100, and the simple interest amount is going to be 225 multiplied by 7.5 multiplied by 3 divided by 100, and the answer is 50.625. 50.625. So this is the simple interest. This is only the interest amount that I'm going to receive when I will invest $225 for 7.5% of rate of interest for next 3 years. So what will be my final amount in the bank? So final amount in the bank will be the principal amount that I have invested plus the interest that is generated for the last 3 years. So it is going to be 225 plus the interest, which is 50.625. This is going to be $275.625 as the final amount in the bank after 3 years. Now let's check how much amount I will receive if I will invest the same principal amount uh, at compound interest. So let's check. Compound interest formula gives you the direct amount. So this formula is for direct amount. So amount is P 1 plus R upon 100 raised to T, where again P is the principal amount, R is the rate of interest, and T is the time period for which you are investing the money. So P is 225, 1 plus R, that is 7.5 upon 100 raised to T, that is 3 years. What we have to do, we have to substitute these values in the calculator to the 225 multiplied by 1 plus 7.5 upon 100 raised to 3, and we'll get the answer as 279.52, correct up to 2 decimal place. So this is the amount. Now we can clearly see that in this case we are getting 279 at compound interest, and at simple interest we received only 275. So the amount in case of compound interest is higher as compared to simple interest. Now the big question here is, why is this happening? If we are investing the same money for same rate of interest for same time period, why we are getting more money at the end of 3 years at compound interest as compared to simple interest? Because in the simple interest case, the principal amount that we are investing 225 is exactly the same for the remaining 3 years at 7.5% of rate of interest. But in case of compound interest, the principal amount, which is 225, is increasing by 7.5 percentage every year, and that is how the principal is changing every year. First year your principal amount is 225. Next year your principal amount will change to 225 plus additional 7.5 percentage. Another next year, like the second year, it will be 225 plus 7.5, and then another 7.5, and that is how the principal amount is increasing, and hence your final amount is also an increased amount, which is 279.52. With this, let's try to solve problems now. I suggest, if you don't have your notebook with you, please bring a pen and paper and try to solve the questions with me so that you can also practice it. Let's try to solve question number 1 now. We have 5 questions based on simple interest, first 5 on simple interest and the last 5 on compound interest. So if you already know simple interest, you can switch to compound interest. If not, let's try to solve and understand simple interest first and then compound interest. Question number 1, it says James invests £200 for 1 year in the bank account. The amount pays simple interest at 3%. This much amount for 1 year for 3% per annum. Work out the total amount of money in the account at the end of the year. So we have to find the amount, but this is simple interest. So let's find the simple interest first. Simple interest is going to be P into R into T upon 100. Our principal amount is 200. Time period is one year. Rate of interest is 3%. So 200 into 3 into 1 divided by 100. 0, 0 cancel out. So 2 into 3 is 6. So simple interest amount is 6. But the amount is principal plus interest. So principal is 200 plus interest is 6. So answer will be 206. So amount is 206 pounds at the end of 1 year at a rate of 3% per annum for the principal amount 200 pounds. Let's move on to question number 2 now. Question number 2, it says Sammy invested 400 pounds for 2 years at 5% per annum at simple interest. 400 for 2 years, 5% per annum simple interest. Work out the total interest Sammy gets. So in this case, we only have to calculate the simple interest. So simple interest is again PRT upon 100. The value of P is 400. T is 2 years. R is 5%. Let's substitute the values. So 400 multiplied by 5 multiplied by 2 divided by 100. 0, 0 cancel out. 5 into 2, 10. 10 into 4, 40. So answer is simple interest is 40 pounds. And that's the answer. Let's move on to next question now quickly. Question number 3. It says Faith invests 800 pounds for 3 years in the bank account. The account pays a simple interest at a rate of 0.4% per year. Work out the total amount of interest. Amount of interest means they are asking for the simple interest only. Total amount of interest Faith has got at the end of 3 years. So this is the time period. This is the principal amount. This is the time period already given. This is the rate of interest. So let's try to solve it. Simple interest is P into R into T upon 100. Let's substitute the values. 800 into R, that is 0.4 multiplied by time period 3 divided by 100. So 0, 0, 0, 0 cancel out. Let's multiply 8 into 0.4 into 3 and the answer is 9.6. So he will receive 9.6 pounds as the total amount of interest at the end of 3 years. Let's move on to question number 4 now. If you have reached till here and if this is helpful to you, do subscribe the channel and like the video so that I will get to know that these videos are helpful to you, and I'll keep on making such videos. If you have any personal suggestion from Cambridge Mathematics, from the topics that generally we solve from IGCSE and even from lower secondary, even from AS and A level, if you're watching this right now, you can share the suggestion in the comment section and I will definitely make a video and post it for you guys. Let's try question number 4 now. It says Johanna invests £800 for 20 years in the bank account that is paying simple interest. At the end of 20 years, she earned 320 interest. Work out the annual rate of interest. So in this case, we have to find the rate of interest. Simple interest is known to us. Time period is 20 years and P is £800. We have to find the simple interest. We know that SI is equals to P into R into T upon 100. We have to find the rate of interest. Simple interest is 320 is equals to principal amount 800. Rate of interest is unknown, which we have to find. T is 20 years divided by 100. So 0, 0, 0, 0 cancel out. 320 divided by 8 multiplied by 20, which is equals to R. 0, 0 cancel out. 2 ones are 2, 2 16s are 8 ones are 8, 8 twos are. So rate of interest is going to be 2% per annum, or we can say rate here 2, because percent we have already applied, so rate will be you can say 2% per annum. The value of R is 2. Let's move on to the next question, question number 5. Prissy invests $2,000 £2,000 for 4 years in saving account that pays simple interest. At the end of 4 years, Prissy has this much in her account. Work out the annual rate of simple interest. We have to find the annual rate of simple interest. Simple interest is P into R into T upon 100. Percy has this much in her account. This is the principal amount. This is the time period. And they're asking us to work out the annual rate of simple interest. We have to find R, but we don't have SI, but we can find SI because the amount in this case has given to us. Prissy has 2140 in her account. So amount is equals to principal plus interest. Amount is known, principal is known. We have to find interest. So interest will be amount minus principal. Amount is 2140 minus principal. So this is your amount minus principal, that is 2000. So that is going to be 140 basically. So interest is 140. Now let's find the value of R by substituting the value of I in the main SI formula. So 140 is equals to 2000 into rate of interest, which is missing, multiplied by T, that is 4 years, divided by 100. So 0, 0, 0, 0 cancel out. 140 divided by 20 into 4, that is 80, which is equals to R. So simply R is going to be 140 divided by 8, and the answer is 17.5. That's the answer. That's the value of R. 17.5 percentage is going to be the rate of simple interest that is charged annually. Let's move on to question number 6 now. Starting from question number 6, we have these questions based on compound interest. So let's check how to solve problems based on compound interest. It says Toby invested £4,500 for 2 years in a saving account. He paid 4% per annum compound interest. How much did Toby have in his saving account after 2 years? So they're asking the final amount that Toby have in his account after 2 years. So the amount formula is amount equals to P 1 plus R upon 100 raised to T, where T is the time period. This is your principal amount 4,500. Time period T is 2 years, and rate of interest R is 4% given to us. R is 4%, which is given over here. So let's substitute all the values in the formula. So 4,500, 1 plus 4 upon 100 raised to T. T is 2 years. Let's solve this. Put the values in calculator. 4,500, 1 plus 4 upon 100 raised to 2, and the answer is 4867.2, and this much pounds Toby will have in his account after 2 years. So let's move on to question number 7 now. I also suggest, if you have reached till here, always pause the video and try to solve that particular question and then check your answer at the end. This will be helpful. Now let's solve. Question number 7, it says Henry invests 4,500 pounds at a rate of 5% per annum. At the end of n complete years, the investment has grown to this much. Find the value of n. So in this case, we have to find the value of n, which is the time period, but we already have the amount. We know that amount is equals to P1 plus R upon 100 raised to T. This is the amount given to us. This is the rate of interest, and this is the principal amount. And the time period t, which is written as n, is missing. So let's substitute all the values. We have 5469.78, which is equals to 45001 plus r, that is 5 upon 100 raised to t, which is n given to us, and we have to find the value of n. So let's divide 5469.78 by 4500. So we will get 1 plus 5 upon 100, that is 105 upon 100, or we can directly write 1.05 raised to n. Let's divide this in the LHS. So we have 5469.78 divided by 4500, and the answer is roughly 1.2155. Write correct up to, like, this is not the final answer, so try to extend the decimal values. So we should write up to like 4 decimal place. So this is equals to 1.05 raised to n. Now in this case, we have to find the value of n. And how do we do that? There are two approaches from here. One is logarithm, which is not in your syllabus, and another one is hit and trial method. So we should use hit and trial method because logarithm you're going to use and learn in AS and A levels. So let's check this. Now we have to understand what should be the power of this value 1.2155 raised to what will give you 1.05, or not like this, 1.2155. So basically you have to think like this: 1.05 raised to what will give you 1.2155. So that you can do it in your calculator. If I'm doing 1.05 raised to, let's say, 12 randomly, I'm getting 1.79. But I don't need 1.79. I want 1.21. I took 12. Let me reduce from 12 to 7. When I'm doing 1.05 raised to 7, I'm getting, so I'll write it over here. When I'm doing 1.05 raised to 7, I'm getting 1.407. So this will not be applicable. Let me check with 5 directly. When I'm doing 5, 1.05 raised to 5, I'm getting 1.276, which we cannot consider. Let's check 4. When I'm doing 4, 1.05 raised to 4, I'm getting 1.2155, exactly the same answer. That means the value of n will be 4. And that's how we calculate the value of n when the exponent value is missing, using hit and trial method. Logarithm is another method, but for that, let's wait for another video where I'll explain logarithm and how to use logarithm to find the exponential values. Let's move on to the next question now. Let's try to solve question number 8 now. It says a company bought a van that had a value of 12,000 pounds. Each year, the value of the van depreciates by 25%. Work out the value of the van at the end of 3 years. So the time period T is 3 years here. But it says the value depreciates. What does this mean? Depreciates means the value of the car is decreasing. So in this case, when we have to find the final value of the car, the initial value of the car is 12,000 pounds. We have to find the final value of the car. So final value here, final value will be initial value and then 1 minus r upon 100 raised to t. This formula is used in case of depreciation. This is the case of exponential decay. So whenever the value of anything, either house or a car or any article which is reducing every year at a certain percentage, there we use this formula where we have to find the final value. The initial value is given to us and the rate of depreciation is given to us. So we use this formula. It's exactly similar to the formula that we use in compound interest. Because here the value is decreasing, we are using minus in the formula. So final value is going to be initial value, which is 1 2 0 1 minus rate of interest 25 upon 100 raised to t, that is going to be for 3 years. Put this value in the formula and we'll get the answer 1 minus 25 upon 100 raised to 3, and I am getting 5062.5. 5062.5. So this is the final value of the car after 3 years, because it was depreciating at a rate of 25% per year. So this is the final answer. Let's move on to question number 9 now. Question number 9, it says Bill invests £500 on 1st of January 2004 at the compound interest rate of R percentage per annum. The value V pound of this investment after n years is given by this formula. V is equals to 500 multiplied by 1.045 raised to n. It says write down the value of R. We already know the formula for increase, or in case of compounding, it is 1 plus R upon 100 raised to t. So we have V is equals to, can we write this 500 multiplied by 1 plus 4.5 upon 100 raised to n. So what I am doing, I am breaking this 1.045. I am writing 1.045 as 1 plus 0.045. Now 1 plus 0.045 can be written as 4.5 upon 100. So that's what I am writing over here. So the rate of interest R is going to be, we have to find the value of R percentage per annum. So R is going to be 4.5%. That's the answer. Now it says use your calculator to find the value of Bill's investment after 20 years. We have to substitute 20 in place of n. So V is going to be 500 1 plus 4.5 upon 100 raised to n, or you can also use this formula, just substitute the value of n. So let's use that formula. It's the same thing. This was more elaborated. So 500 1.045 raised to 20, and let's find the value. So 500 multiplied by 1.045 bracket close raised to 20, and the answer is 1205.86. So this much pounds. That's the answer. And now let's move on to the last question, question number 10. It says Gwen bought a new car. Each year the value of her car depreciated by 9%. Calculate the number of years after which the value of her car was 47% of the value when new. So let's find out what was the 47% of the value of the new car. But we don't have the value of the new car. So let's start from here. Let's say the value of the new car is X. In that case, 47% of X is the final value. So new car means initial value. Initial value is X, and the final value is 47 upon 100 raised to X, because that's what it's given here. It says calculate the number of years. But find the number of years which the value of her car was 47% of the new value, and we have to find the number of years. So basically we have to substitute in this formula. Final value is equals to initial value 1 minus R upon 100 raised to t, or number of years we can say n here, time period n. It says number of years. Each year the value of car depreciated by 9%. So this is the rate of depreciation. Final value is 47 upon 100 multiplied by X. Initial value is X. 1 minus rate of interest is 9%. So 9 upon 100 raised to the time period n. So this X and this X will cancel out. Here we have 0.47, which is equals to 100. We can say 100 minus 9, that is 81. So 0.81 raised to n. Now again in this case we have to figure out what will be the value of n. So let's check. If we randomly do 0.81 raised to 0.81 raised to let's check 2. So it's going to be more than this. 0.81 raised to 2 is 0. Okay, 0.81 raised to 2 is 0.6561, which we will not consider because we want 0.47. So what can be the other answer? Even lesser than 2. So can I write 0.81 raised to, if I write 1.5, it's too much. If I write 0.81 raised to 0.9, no. 0.81 raised to 4 is 0.43. When I am writing 0.81 raised to 4, I am getting 0.4304, but we want 0.47. So try to increase this. Instead of 0.81 raised to 4, let's try 0.81 raised to 5. Oh, not possible. 0.81 raised to 3.5. Okay, so when I am doing 0.81 raised to 3.5, I am getting precisely 0.47829. 0.47829, which is close to this 0.47. But let's check 0. They calculate the number of years after which the value of a car. So number of years. So if it is 3.5, we can write down the value of n as 3.5. So the value, it says calculate the number of years after which the value of her car was 47% of its value when new. So that is 3.5 years. If you want to check precisely, we can check 3.6 also. 3.66 not possible, and if I check 3.4, that is also not possible. So exactly it is 3.5. Yeah, so that's the answer. With this, we are done with compound interest and simple interest formulas. The first 5 questions were simple interest and the last 5 questions were based on compound interest. If this is helpful to you, do consider sharing it with your friends so that they can also learn. And do like the video, subscribe the channel for more of such contents. And that's it from my end. Bye everyone.